All right, today we're stepping into the ring for a real David versus Goliath showdown in the world of AI. We've got a classic matchup, a brand new contender built from the ground up, going head-to-head with a heavyweight world champion.
And this really gets to a fundamental question, doesn't it? When you're faced with a tough new problem, is it better to learn everything from scratch or to lean on past experience? Well, we're about to see two AIs put that exact question to the test.
And the challenge they're up against? Oh, it is brutal. Imagine you have to learn to identify dozens of different things, but you only get to see like a handful of pictures for each one. For an AI, that's an incredibly difficult, almost impossible task.
To be specific, the AI has to learn how to tell the difference between 26 different categories. That's 26 unique labels it has to get right. You've got animals, vehicles, you name it.
But here's the real kicker. On average, it only gets about 9.5 images for each of those categories. That is just an insanely small amount of data. I mean, most AI models train on thousands, if not millions of examples. This is like learning on an absolute shoestring budget.
Now, this chart right here, it just lays the problem bare. You can see the issue right away. Sure, some categories, like rodent, have a decent number of examples, but look way down at the bottom. Train and camelid have just a couple of images. The AI has to figure out what a train is from maybe 2 or 3 pictures. That's the gauntlet.
And this really brings it to life, right? It's not just about numbers. These are actual images. The AI needs to look at that picture of a cat and know it's a feline and not, say, a canine. It has to tell that airplane apart from that truck. With so few examples to go on, it's a massive, massive challenge.
Okay, so the stage is set, the challenge is clear. Let's meet our two competitors.
So, in one corner, you've got the contender, a custom-built neural network, or CNN. Think of it as a talented rookie. It starts with a total blank slate, knows nothing, and has to learn everything about these 26 categories right here, right now. And in the other corner, we have the champion, DINOv2. This thing is a massive, pre-trained model. It comes into the fight with worldly experience, having already seen 142 million other images. It just needs to adapt its vast knowledge to our specific problem.
So, we gave both AIs the exact same data, the same amount of time to train, and then we tested them on brand new images they had never seen before. So, how'd they do?
And bam, here it is. This is the knockout punch. Just look at the bars on the right. That's the performance on new, unseen images, which is the real test. The champion, DINOv2, sails past 40% accuracy. Our contender, the custom CNN, it barely managed 9%. It was a complete and total landslide.
I mean, to put it simply, the seasoned champion performed more than 4 times better than the rookie. This wasn't just a win, it was absolute domination.
So this brings us to the million-dollar question, why? What exactly happened under the hood that led to such a ridiculously one-sided result? Let's break it down.
To really understand the victory, you first have to understand the failure. Our rookie contender, the custom CNN, made a classic textbook error when trying to learn from such a tiny amount of data.
And that mistake is called overfitting. This slide nails the explanation. Instead of learning the general idea of what a cat is, pointy ears, whiskers, a certain shape, the AI just memorized the specific pixels of the few cat pictures it saw. It was like it aced the practice quiz, but then completely bombed the final exam when it saw new photos.
And this number right here, this is the smoking gun. The contender had a 63% overfitting gap. That's the huge difference between how well it did on the data it memorized versus the new data it actually had to understand. It was just a terrible student, totally focused on memorization, not real learning.
Okay, so we know why the rookie crashed and burned, but how did the champion win so decisively? Well, it turns out DINOv2 walked into the ring with a massive, almost unfair advantage. And this is the secret weapon. This quote from the source material just says it all. The champion arrived with pre-trained eyes. Because it had already analyzed 142 million images from all over the internet, it already understood the basic building blocks of vision, things like edges, textures, shapes, and patterns.
So its process was completely different. In step 1, its powerful eyes looked at an image of, say, a truck and instantly recognized the core features: wheels, a windshield, a rectangular cab. Then, in step 2, a tiny, simple part of the AI was trained to do just one thing: connect those rich features to the labeled truck. It wasn't learning to see, it was just learning to name what it already saw.
So at the end of the day, the champion's victory wasn't about learning faster. It was about not having to learn from scratch in the first place.
It was simply applying its lifetime of experience to a new, specific task. And that powerful strategy is called transfer learning.
This final report card really tells the whole story. While our first look showed a big gap, these are the final numbers. On validation accuracy, that's the score on the real test, the champion DINOv2 hit 54.6%, while the contender CNN only got 14.8%. The champion was just way, way better at generalizing what it knew.
So what's the big takeaway from all this? Well, the lesson from this experiment is crystal clear. When you don't have a lot of data, building an AI from a blank slate is basically a recipe for failure. The real superpower is leveraging the vast pre-existing knowledge of these giant foundation models. That right there is the essence and the power of transfer learning.
And that leaves us with a final thought. This technology isn't just for telling cats from dogs. It can be applied to medical scans, satellite imagery, manufacturing defects, the list goes on. So I'll leave you with this question. If you had access to that kind of power, that much built-in experience, what problem would you want to solve?